To support NASA's Artemis mission, the banker backers decided to focus on designing a soft, wearable robot aimed to maintain the astronaut's paraspinal muscles and reduce the recovery time from prolonged time spent in microgravity environment while meeting NASA standards for safety and environmental protection.
In the light of the need to know which areas of the paraspinal muscles activate during exercise, we conducted a thorough investigation and research. Our results showed that the most suitable location for the electromyography sensors to monitor the muscle's right area is the multifidus, which you can see here in the picture. In addition, we applied textile actuators that allowed the astronauts to exercise and train their back and torso to maintain muscles during their 90-minute exercises, using a physical training regimen that we believe will be effective for the astronauts.
We turned to 3D printing to create upper and base molds 9 by 1.5 centimeters for our silicon actuator using PETG filament. To fill the molds, we prepared a mixture of 1:1 ratio using the EcoFlex Dragon skin for the molding. The density of the silicone rubber is similar to water, has a low viscosity formulation, does not require vacuum degassing, and has a 663 elongation stretch. If necessary, use a vacuum chamber to help degas air from the actuator. To aid the release of the CC actuator, apply Ease Release 205, a liquid general-purpose release agent for making molds and casting parts.
We combined both and have them oriented, along with the parchment paper. We distributed a tiny amount of 1-part silicone glue between the upper layer and the base to seal them together to be cut apart. There were 7 tests in total. The silicone actuators are very robust and could be damaged at 10 psi. However, below 10 psi, the prototype withstood the range of thresholds generated by muscle without being deformed or broken. If any damage can happen to the actuators, we can quickly fix them with a bit of silicone glue by adding the silicone at certain places where we see holes. We designed a suit, manually sewed 4 Velcro pieces to it, and attached the soft actuators and an air pump controlled by Arduino. The soft wearable suit also will require a small amount of equipment, specifically Velcro shoes which astronauts can stand while exercising, and a small smart air pump to produce a range of resistant force and support different exercises.
We insert a silicone tube into the actuator's chamber to control the silicone actuators to ensure the astronaut have exerted enough load on the bones. We measured the voltage output from a complete muscle contraction and relaxation cycle using the electromyography sensor. To have a precise plot graph, we introduced MATLAB to help us cancel the noise and pinpoint the voltage values upper bound, contraction, and lower bound, relaxation. The soft wearable robotic suit will incorporate the collected data to determine whether the astronaut's exercise reaches the muscle firing threshold and gives feedback accordingly. Okay, so we have a flow chart here showing that how our software works with the wearable robotic suit. And at first, we are going to power up the suit and set everything at standby state. And then we're going to read values, read sensor values, and then we're going to test if either the sensor values pass the threshold. If either one of them fails the test, we're going to come back here and then set everything to standby state again. And then while doing so, we're also going to send the values to this database for future analysis. Once both of these sensor values are true, we're going to come down here and use the actuator to increase the resistance. And then we're going to set it to standby state again, and then read the sensor values. And then once again, we're going to test the sensor value with a different threshold. And then if it fails to pass the threshold, we're going to come over here and then light up the indicator. And then set it to standby state again, and then test it once again. So if the sensor value passed the threshold over here, we're going to come over here and then light up a different indicator. Shows that it's a good exercise. And then we're going to increment the rep count. And then we're going to send the data to another database for further analysis. And then after everything is finished, we're going to come back here at the beginning so we can start another loop.
Our future work is to work on a very soft wearable suit for space travelers and potentially advanced treatment for people on Earth, as NASA plans missions to the Moon and Mars. The astronauts will be far from assistance and may need to perform a strenuous activity in a zero-gravity environment. Future work may consist of using an inertial navigation system consistent of accelerometer, gyroscope. Our soft, wearable suit is a promising method for maintaining muscle mass and bone density without being dependent on the gravity of the Earth.